Good morning, all. Myself, Sagar. Now we are going to learn about binary search. It's a searching algorithm which is used in sorted array, which can be in ascending or descending order, and we search by repeatedly dividing the search interval in half. So, this algorithm helps to find the index of the required element or key, and if it's not found, we are going to return -1 or some message, some kind of message we are going to print, which notifies that the element is not present in our array. So throughout this presentation, I am going to consider the array to be in ascending order, and some of the variables that I am going to use again and again is low, mid, and high. Low is for the leftmost index of the considered array. High is for the rightmost index of the considered array, and mid is the middle index of the considered array. So now let's move to the working. First, we find the middle element. Then we compare the middle element with the key value. If it's equal, then we will stop there. Otherwise, it falls into two cases. Like either of two cases, it can fall. If key value is less than the middle element, we are going to consider the left part of the array. And if key value is greater than the middle element, we are going to consider right part of the array starting just after the middle element. So we are not going to stop here. It will be keep it these steps are going to be iterated again and again until we find our middle element gets equal to key value or while condition gets false. In both of the condition, it's going to stop. So uh, the condition for the while loop is low less than equal to high, and now let's understand it with the help of one example. So we are considering one array whose size is 15, and our key value is 33, low is 0, and high is 15 minus 1, that is 14. So first iteration starts now, and the middle value is, first we find the middle index. Middle index is low plus high by 2, that is 0 plus 14 by 2, that is equal to 7. So we get that our key, that is 33, is less than 53. So key is less than mid, right? So we are considering left part of the array. So for that, we have to do high equals to mid minus 1. Now we are going to start the second iteration. We find the mid again, that is 0 plus 6 by 2, that is 3. We find that our middle value is less than our key value. So we are going to consider the right part of the array. So low is equals to mid plus 1, that is 4. Now we are going to start the third iteration. We find the mid index again, that is 5. Our middle index value, our mid value is greater than the key. So we are going to consider left part of the array. So high equals to mid minus 1. So now fourth iteration will start, and low and high are at the same position. You can notice that this is also the last iteration of the while loop. So mid is equals to low plus high by 2, that is 4 only. Middle value is 33, which is equals to our key value. So at this point of time, our middle index is going to be returned. So that's the explanation of this example. Now let's move to the pseudocode part. We are using a search algorithm. We are using the search function for running this algorithm. It's taking two parameters, array and target or key. We are initiating low equals to 0 and high equals to size minus 1. We are using a while loop. Condition for while loop is low less than equal to high. So first we are finding the mid equals to low plus high minus low by 2, and it's intentionally done because when we do mid equals to low plus high by 2, then like in some cases the array can be so large that high and low are also very large. So for in that case integer overflow can happen. So we have written low plus high by 2 as low plus high minus low by 2, and high minus low helps in escaping from integer overflow. After that, we compare the middle value with the key value. If it's equal, then we return the middle index. Otherwise, we go in the other two cases. Like either if it can go into either of this else if or else. If array mid is greater than key, then we are going to consider left part of the array. So for that, we have to do high equals to mid minus 1. And if it falls in this else, which had a condition array mid is less than target or key, so for that we are going to consider right part of the array. So for that we have to do low equals to mid plus 1. So as you can see that in this else if and else conditions there is not any kind of return. So we are going to keep iterating it again until we find our middle element equals to our key value. And if nowhere it's found, then while loop will automatically end the loop after the or after all the iterations are over and low greater than high happens. So for that case, we have to return -1 or some message. So it's all about the pseudo code. Let's analyze the time space complexity. Time complexity of this is O of log base 2 n. Since binary search reduces the search space by half at each step, the maximum number of iterations required to find the target is log base 2 of n, where n is the size of the array. So the time complexity of binary search is O of log n. For the calculation purpose, you can do like this. In the first in the first iteration, if our middle element is not equal to the key value, you are reducing the search space by half. So n becomes n by 2. So n by 2 is now the search space. For the second iteration, it's going to be n by 2 square. For the kth iteration, it is going to be n by 2 raised to k. Let's say that in the worst scenario, you have to iterate to the maximum times until you are left with only one element as a search space. So for that, n by 2 raised to k equals to 1, and when you will simplify it, you will get k equals to log base 2n. So that's how this O of log n came. So now let's understand the space complexity. It's O of 1 only. Binary search only uses a constant amount of additional space for the two pointers, that is low and high, and the middle index variable. So the space complexity is also O of 1. So that's all about the binary search algorithm. Thanks for being here up to now.